recorded the other lesson on Monday, I think. Okay, so we are going to go through this. You're supposed to, this was your homework. Now a curve has got that. Find dy, it means the gradient. Remember, if I have a straight line has got a constant gradient. But if I have a curve like this, the gradient is always changing. So the gradient will depend on any pointer on this curve, is always changing. We can have a turning point where the gradient is 0 at a turning point. Then they can tell that this is negative gradient, positive gradient. So the gradient is changing. So that's why now we use this. So we want to find the gradient. So when we say dy over dx, we are finding the general gradient of the curve with respect to x. Okay. So to find that, it's easy. If I have x to the power of n, it's simply n to the power of x, n minus 1. That's the formula. So there is 2 times 1 there, which is 2. X to the power of 2 minus 1 is now 1. So it's 2x. There's no need to write 2x to the power of 1. Minus, we said on Monday, differentiation of x. X means x to the power of 1. If you multiply that, it's 1x to the power of 1 minus 1. So it's 1x to the power of 0, which is 1. Anything raised to the power of 0. So this is always 1. So it's minus 4 there. Then differentiation of a constant, by now you should know this is simply 0. So that's your answer there. 2x minus 4. Now find the coordinates of the minimum. So the minimum, it means it's a turning point like this. At the minimum is the stationary point. So at the minimum, dy over dx is equal to 0. So then we are saying our gradient, 2x minus 4 is equal to 0. If you equate, move for the other side, you find that x is equal to 2. That's your x coordinate. But you want to find the y coordinate. You simply use your equation of the curve. The equation of the curve is y is equal to 2x squared, x squared minus 4x plus 21. So like this, when x is equal to 2, let's substitute 2 squared minus 4 multiplied by 2 plus 21. This gives us 4 minus 8 plus 21. Can rearrange this, gives us 25 minus 8, which gives us 17. So what's the turning point? 2, 17. It's the minimum. Are we together? Local minimum. Now an equation has got this. Find dy over dx. So straight away, this gives us 0. That's what we said. Differentiation of x is 1. We've just explained it just now. Minus 2x to the power of 1. So it's 2x like that. That we are done. 1 minus 2x. Then find the coordinates of the maximum. Now it's a local maximum. Again, same thing. At that's a turning point, stationary point. Dy over dx is equal to 0. So it means 1 minus 2x is equal to 0. 2x is equal to 1. Therefore, x is equal to half. So I now know my x coordinate of my turning point. To find my y coordinate of my turning point, I have to use the equation. So y is equal to 1 plus half minus half squared. Find that in your calculator. So it's half plus 1 plus half minus a quarter, I'm sure. If I want to do simple maths here without a calculator, half is as good as 2 over 4. 2 quarters minus a quarter gives me a quarter. So it's 1 and a quarter. 1 and a quarter is 5 over 4. Are we together then? Mr. Ryan? Making sense? I saw most of your answers were correct. Now the curve has got an equation there, like that. So sometimes it's just given a diagram. Work out the stationary points. So you can tell that this is a local maxima. That's what you mean by a local maximum. This is a local minimum. At both points, dy over dx should be equal to 0. Clear now? Dy over dx is equal to 0. Now, this is the easiest one. Okay, why I'm saying that was the x value, I can tell it's 0. You know, let's differentiate this first. So dy over dx is equal to 3 what? 3x squared. Multiply that, you get minus 6x. 1 gives you 0. So you're saying 3x squared minus 6x is equal to 0. Factor out 3x brackets, x minus 2 is equal to 0. So it means x is equal to 0, was this 3x is equal to 0, or x is equal to 2. So it means this point here, the x coordinate is 2. So to find the y coordinate when x is equal to 2, we go to this and say the value of x is 2 cubed minus 3 brackets 2 squared plus 1. So you use your calculators. This gives you 8 minus 4, that's 12. Is that correct? Yes. Plus 1. So if you add, that's 9 minus 12, it gives you negative 3. So it means this is minus 3. So the coordinates B is 2, negative 3. Then A is 0, if you want this 0 here. So if you equate 0 into this is 0, this is 0, squared plus simply 1. So this value here is 1, the y value. So it's 0, 1. Those are the coordinates of the turning point. Now I've got another graph. Y is equal to that. Makanaka, yeah, there. I heard that there was a problem in Shreds or something. Brandon, is Brandon there? Something to do with their copper, their fiber. Brandon, are you in the lesson? Anyway, maybe their network hasn't been fixed. So Tawana, does that make sense to you there? So 3 times, we get what? 6. Then this, you subtract my 3 minus 1, you get x squared. Minus 2 times 9, 18. You subtract, you get x to the power of 1, so it's simply x. Then this, we said this always gives us 1. So it's plus 12. Then the constant gives us 0. Make sense?
Yes, sir.
So that's the first part. Now to work out the turning coordinates of the turning point, so it means dy over dx should be equal to 0. Now it means this whole thing needs to be equal to 0. So let's see how you do. So if you're someone who is good in maths, you can see that 12 can go into everything. Divide everything by 12. You have x squared minus 3x plus 2 is equal to 0. Factorize, because it can be factorized. 2 numbers that when you multiply give you positive 2, when you add them give you negative 3. Minus 2 minus 1 is equal to 0. So straight away x is equal to 1 or 2. Which means I now know the x coordinates of those 2 turning points, but I don't know the y coordinate. I need to find the y coordinates. We're using, remember we have the equation. So we're simply substituting. Let's substitute 1 there. So it's 2 brackets 1 cubed minus 9 brackets 1 squared plus 12 brackets 1 doesn't change anything, minus 1 does not change it. So this is 2 minus 9 plus 12 minus 9. Like that, minus 9 plus 12. So 2 plus 12, 14. Minus 9 minus 9 minus 18. So that should give you negative 4. Like this. How would you get that? Okay, sorry, what's happening is I'm using what could I call it? I'm still with my Zo. The Zo guys haven't come, so I'm using data. That's why you see, if I'm using Zo, that never happens. Sorry, bro. Sometimes it happens with when you're using Econet. So can you, what value do you get there from your calculators? So I'm sure this is 8 times that 16 minus 30. Can you use your calculators? Minus 36 plus 24, I think, minus 9. So it means 16 plus 24 minus 36 minus 9. What do you get? So that is positive 3, if I remember. What values do you get? You're saying 24, 16 plus 24, that's 40.
I'm getting negative 5.
Negative 5.
Yeah.
Is that correct?
Yes, sir.
Minus 9 brackets, wait a minute, 2 brackets squared plus that multiplied by 2 minus 9. Negative 5, correct. Negative 5 there. Now, I want to go further. This question never asked you about the nature of those turning points. Huh? What if you asked about the nature of the turning points? What do you do? The nature of the turning points. Whether it's a local maximum or those two coordinates, huh? we find the second derivative. Our first derivative is this. So we find, remember, the second derivative. So we know that dy over dx is equal to, we said 6x squared minus 18x plus 12, like this. That's our first derivative. So now we find the second derivative. If you didn't know that, you find the second derivative. So you're deriving this again. So if you do this, it's 12x minus 18. This is simply 0 there. Then you use these x coordinates. So when x is equal to 1, let's do that so that we find the nature of this turning point. When x is equal to 1, this will be 12 multiplied by 1 minus 18, which gives us negative 6. So if d squared y, second derivative, is less than 0, it means it's a local maximum. So it means coordinate, this coordinate here is a local maximum. Now let's identify when x is equal to 2, whether it's a local maximum. So we are using the same, it's 12 brackets 2 minus 18. This is 24 minus 18, it's a positive 6. So d squared y over the second derivative is greater than 0, it's a local minimum. So this coordinate here is a minimum. Clear? Work out the stationary points of this curve, 4 marks. So to work out the stationary point, we know that its stationary points dy over dx should be equal to 0. So let's find dy dx. Tawana, are you there? Are you still there in the lesson? So what will be the answer there? Look at this straight away, you can give me the answer. What will be dy over dx there? 3x squared minus 3, yeah? Was x always gives you 1. So that's, but we're saying this should be equal to 0. So 3x squared minus that is equal to 0. Factor out 3 brackets x squared minus 1 is equal to 0. Divide everything by 3, you have x squared minus 1 is equal to 0. How do you do this factorization? Difference of 2 squares. X plus 1, factor of x minus 1 is equal to 0, which means x is equal to negative 1 or 1. How would you get that? The points, but
Yes,
they want
sir.
the points. They want the points. Now we want the coordinates. Huh? So we know that the x here will be 1. We'll find the y just now. Then the x here will be 1. Let's just use the equation. So when this is -1, substitute there. -1 cubed minus 3 brackets -1. So from your calculator, this gives you -1 plus 3, which is 2, I think. Then the other one, 1, simply 1 minus 3, which is -2. Can you find that from your calculator? Clear now? Clear, right?
Yes, sir.
If I was to look at, if the question said now determine the nature of the stationary points, I will do second derivative of this. So that will be simply 6x, because this is 0 here. Then I substitute this. If I multiply by this, 6 multiplied by -1, it simply gives me -6. So it means this is a local maxima. Make sense? Then if I say 6 times 1, I'm getting a positive. This is a local maxima. It's going to help us to draw. They're going to ask you to draw a sketch just now. There, we now know that this is a local maximum. This is a local minimum. Okay. So we know that point -1, 2, some also 2 somewhere there is turning like that. Then we now know that 1, +1, -2, it's a local minimum. Like that, since we said it's a local, yes, local max. Okay. Now, so look at this. Then what, when x is equal to 0 here, what will be y? If we substitute 0 cubed minus 0, simply 0. So this curve is also passing there. So what they're simply interested in, there is turning, then it goes to 0 like that. Okay, that curve. Then it's going to turn here since it's a local minimum on this point here. Make sense? Of course, but your turns will be not
Yes, sir.
okay. A curve is that find dy over dx. So let's do that. 4 times 3, 12.
Perfect.
Reduce this by 1. Sorry. 12x to the power of 3 minus, multiply that by 3 is 36, reduced by x squared. Then this simply gives you 0. You're done. Then let's do the second derivative. So you're picking it from here. So 3 times that is 30 what? 36 x squared reduced by 1. Then 36 times 2 is 72 x to the power of 1. So simply x like that. See, these networks are not reliable. These tier 1 networks, sorry, Econet line, if it's so, it doesn't do that. Okay, something wrong with my fab. Now, so show that C has, okay, C has got a stationary point at x is equal to what? Stationary point at x is equal to that. So stationary point dy over dx is equal to 0. So this whole thing here should be equal to 0. 12x cubed minus 36x squared is equal to 0 at stationary point. Okay, divide by 12x. What's happening? Divide by 12x squared, I think so, brackets. If you divide there, you get x. If you divide there, you get minus 3 is equal to 0. So I'm interested in this part here, which is x minus 3 is equal to 0. So x is equal to 3. That's what they wanted you to show, that it's one of the turning points. Can you see that? Determine the nature of this stationary point, giving you a reason. So there's a reason why they said do the second derivative. We have done the second derivative. Huh? Then we have to test when x is equal to 3, whether it's a local maximum or what. So 36 brackets 3 squared minus 72 multiplied by 3. Can you use your calculator? Find if it's positive or negative. get a positive. Huh? So it means it's a local minimum because d squared, gx squared at x is equal to 3 is greater than 0. Mr. Ryan. Work out the coordinates of the turning, determine their nature, you see, and it will be like 10 marks in your exam or 8 marks. So let's do it stage by stage. You now have an idea. So dy over dx, finding the gradient, so minus is equal to minus 3x squared, I'm sure you can tell there, plus 24x minus 36. First, clear now? But now we have to equate that to 0, this whole thing. So 0 is equal to minus 3x squared plus 24x minus 36. If I know my maths very well, I can divide this whole thing by 3 so that I get negative x squared plus, if you divide by 3, 8x divided by 3 minus 12. Then if you want, you can divide the whole thing by negative 1. So this is 0 is equal to x squared minus 8x plus 12. Then let's factorize. I've divided by negative 1. Let's factorize x. Looks like it can be factorized. Yes. So x minus 6 minus 2 was minus 6 plus that gives you negative 8. So it is equal to 0. So it means x is equal to 6 or 2. I now have the points, the x coordinates where the curve is turning. So I have 6, but I don't know the y. Then I have the coordinate as 2, I don't know the y. Then I use my original equation. Let's go and equate when x is equal to 6. So we're saying negative brackets 6 cubed plus 12 brackets 6 squared minus 36 plus 6. Let's use our calculator and use your head. Don't forget to write that negative first. Brackets 6 cubed plus 12 brackets 6 close brackets squared minus 36 brackets 6. I'm getting 0.
Okay.
Are you getting 0?
Yes, sir.
Then let's do this for when x is equal to 2. So we're saying negative 2 brackets cubed plus 12 brackets 2 squared minus 36 brackets 2.
I'm getting negative 32.
Okay. Minus 36 brackets negative 32, correct. So that's the y negative 32 like this. Okay, now they said we need to determine the nature of the stationary points. So remember, we now need to work from this, from the gradient. We do the second derivative. Huh? So let's look at the d squared y over dx squared is equal to, if you multiply there, you get negative minus 6x plus 12, I'm sure you can tell, plus 24x, sorry, plus 24, because x is simply 1, and this is 0. So plus 24. Then we are simply substituting there to say when x is equal to 6. So this is minus 6 brackets 6 plus 24. I think that gives you a positive. Oh, sorry, a negative. It's minus 36. So a negative 12 there. Don't need a calculator for that. So now it means d squared it means dx squared dy x squared is less than 0. So at 6, 0, it's a local maximum. Now let's do the same for this one. X is equal to 2.
We're getting 12.
So it's negative 6 brackets 2, like what you're saying, plus that 24. You're getting what? Positive.
Positive 12.
Yes. Positive 12. So it means dx squared dy, or second derivative, is greater than 0 at point that 2 negative. So it's a local maximum, huh? Minimum, sorry, greater than 0, local minimum. Clear now?
Yes, sir.
Ryan, it's clear so far? It's quiet.
That's clear.
The equation of a curve is that where a is a constant, it has a maximum point at that and the minimum point. What a equation. Okay. Anyway, yeah, if they give you this, they want you to think. So, but anyway, it's the same thing that you have been doing. So let's find the gradient first. Dy over dx is equal to 3x squared minus half multiplied by 2. 2 from this, then multiply by x. X to the power of 1 if you want it. Then this, we said this gives you 1. So it's simply plus a, whatever a value is. Then to simplify that, this is simply x squared. This cancels, this cancels. So it's minus x plus a. Okay, but we know that at turning point, this has to be 0. So we're saying a turning point 0 is equal to 3x squared minus x plus a. Can you see that? So we have a quadratic equation, but we are saying in that quadratic equations, our solutions for a quadratic equation, if you look at this, it means x is equal to 1 or x is equal to negative 2 over 3. Makes sense? That's what it simply means. Huh? So now let's use the quadratic formula there, okay, to play around with that. So minus b, so I say minus 1 is 1, plus or minus b squared, that's 1, minus 4 multiplied by a is 3, multiplied by c, which is a, which we don't know, like the square root of that, divided by 2 times 3, like that, okay? So if we do that, then we get to 1 plus or minus 1. If you multiply this, it will be minus 12a square root, like this, or over 6. It's giving us which solutions? 1. Okay, we can work with the 1 so far, or we can work with the other solution, doesn't matter, to give you the same answer. I'll work with 1 now, okay? Now, from maths point of view, let me show you how I do this. I can multiply everything by 1, so that I'll have 1 plus, so I want to eliminate the denominator, brackets 1 minus 12a square root is equal to 6. Clear now, right? Move 1 the other side so that I subtract. Then this side I'm simply left with 1 minus 12a, like this, square root is equal to 5. Because I've subtracted plus or minus. I'll ignore the plus or minus for now. But who knows, okay? Who knows that in maths, if to remove the square root, I can simply square both sides, the square root side. So that I have 1 minus 12a is equal to 25. Clear now? I've squared both sides. So now I have 1 minus 12a is equal to that. Move this the other side. I'm sure your guess is correct. 12a is equal to 24. Okay. Then divide both sides. So 24 divided by minus 12, you get minus 2. Clear? Clear there? That a is equal to negative 2. Huh? Yes. Now, f of x has got exact 2 stationary points, minimum, maximum. Okay, the similar one you to sketch. At BC, B is less than or equal to, this is just a sketch, so it's not difficult. Minimum point is at D, and D is 3, negative 2. 3, maybe I'll put it here, negative 2. So I know that this is a minimum. Then maximum is at BC, where B is between 0 and 3. Between 0 and 3, so you can be somewhere here. I'll put B here. Then C is where? C is between negative. Okay. C is between negative 2 less than or equal to 0. Okay, so C is in between, like this. That's what it means. Okay, so I know that this is the minimum where it's turning like this, and this is the maximum. So it's simply like this. All right, together. Then I'm not worried about the rest. Clear now? Okay.
Yes, sir.
We are done for today. See you at 1:15, those who do bio. I think today's bio is 1:15. Confirm is bio, the next lesson, I'm sure.
Yes, sir.
Okay, so we see you at 1:15.